AND gate. This is a logic digit gate that outputs is true only if when all the inputs are true. In this case, all the inputs, if 1, 1, 1, the output is 1, otherwise is 0. 1, 1, output is 1, otherwise is 0. So this is the principle for the AND gate. The circuit symbol for the AND gate, as you can see here, this is the circuit symbol, logic symbol for the AND gate. Based on two inputs, you have input A and input B. Here you can track the output. For the more than one input, it can be shown in this one. So the AND gate circuit that we see, the AND gate circuit, the AND gate circuit is this one. So in this case, we have two transistors. This is the NPN transistors. The NPN transistors. We have the light emitting diode. In this case, we are direct to the output. Load the resistor here. We have base resistors. This one is R1 and R2 are the base resistors. We have the resistors, this one, are the inputs to control the circuit. So V input is equal to 60 volts supply. As you can see, the actual circuit for the input for the AND gate. This is an actual circuit for the AND gate. It can be shown clearly this way. So as we have said that we have the resistor here, we have the light emitting diode, we have transistors, transistor 1 and transistor 2, base resistors we have here. Also we have the resistors, this resistor, and the other one is this one. We have two switches, and these are the switches. A power supply is this one. This is the power supply, a power supply. So whenever the two switches are on, whenever the two switches are on, these two switches are closed, means that the switches are true. If the two switches are on, that is 1, 1 is equal to 1, otherwise it is false. So in this case, two switches are on. So if we connect to the source, here, so whenever the source is connected, the circuit lights up, diode lights up. So in this case, all the switches are closed. If only one the switch is open, no results on the light emitting diode. So if we open this one, if we also you can open this one, the diode will show no results whenever the switch is whenever the source is connected. Whenever the source is connected, no results on the output since all the switches are open, or either the switch is closed, no results on the output. But if all the switches are closed, if we close all the switches, you can see the results on the lighting emitting diode. The diode lights up only if when all the switches are on. This is the AND behavior. The truth table for the AND gate. Here it is a truth table for the AND gate. As you can see, The output is true only if all the inputs are true. Otherwise, it's false. For the case of OR gate, we have said that if all the outputs, if all the inputs are off, the output is off. Otherwise, it's true. So in this case, all the inputs, if the all inputs are true, the output is true. Otherwise, is false. So these are basic principles. What is the real life application for this? The AND gate can be used firstly for the case of safety interlock. In this case, machine won't start unless safe. For example, motor starts if the door is closed. This is input 1, and the immediate stop is not pressed. This is input 2. Okay. Number 2, the car engine start. In this case, the car starts only if when the key or credentials are valid, that is input 1, and the brake pedal is pressed or gear is correct. This is an input 2. So in this case, the add behavior, the start is allowed only if when both conditions are met. Another application is in password or login with 2 requirements. In this scenario, access is granted only when the password is correct. This is the input 1. The account verification or code is correct. So the AND behavior here, both must be true to get an access. Another one is an automatic lighting. In this case, needs multiple inputs. If it needs the multiple inputs, for example, for this scenario, the output lights on only if when it is dark. This is input 1, and the movement is detected. So the automatic lighting. The AND behavior here, lights turn on only when both conditions occur. Okay, thank you. Let we meet again on the NOT gate.